Howdy, my name is Brady Black, and for my CHEM project, I'm going to be showing the molecular structure of molecules in chemistry. Now, for our first example, we are going to be analyzing carbon dioxide. Now, carbon dioxide is one carbon atom and two oxygen atoms. And to figure out its structure, we are going to analyze the Lewis dot structure diagram of carbon dioxide. Now, to do that, we have to figure out the valence electrons in each atom. So for carbon, it's going to be 4, and for the oxygens, it's going to be 6. And we can figure that out by looking at the group number in the periodic table under the atoms. Now, we take these valence electrons and we put them around each atom. And to create a stable molecule, we're going to first follow a rule called the octet rule. Now, the octet rule states that we need to satisfy the outer valence electron shell of each atom and make it full, which in this case is going to be 8 electrons for oxygen and carbon. So to do this, we're going to bond these atoms together covalently, so it shares the electrons between them. So the carbon will bond to the oxygen and the other oxygen. Now, when it does that, it has 2 electrons left, so it has 2 here, 2 here, 2 here, it's 6, so it's not there yet. We did a bond it one more time, so double bond again, so now it has 4 and 4 with the oxygens. So that satisfies the octet rule for the carbon and both oxygens. Now, when you want to determine the structure, we look at the amount of lone pairs on the central atom of the carbon and the amount of electron domains of the atoms surrounding the carbon, which are the 2 oxygen atoms. So that means that since there's no lone pairs, there's only 2 electron domains, which are the oxygens. So it's going to look like this, which is going to be a linear structure. And according to the Vesper theory, the valence shell electron pair repulsion theory, this states that the electron domains are trying to get as far apart from each other as possible because they're both negatively charged and they're going to repel each other. So this angle of 180 degrees is the farthest they can get apart from each other. Now we're going to analyze a different atom, which is water, H2O. So something different about H2O is that its structure is actually tetrahedral. Now this is because it has, while it does have the same amount of atoms as carbon dioxide, it has 2 lone pairs surrounding the oxygen molecule in the middle. Now this makes 2 lone pair domains and 2 atom domains. So it's going to look like this. This is tetrahedral. There are 109.5 degrees in between each atom. Now it's going to look like this. These are the electron domains. However, since we're analyzing the molecular structure, we're going to take these out. And this is the molecular structure, only the atoms. And it's going to be bent in 109.5 degrees.